Okay, so we will continue today on Introduction to Machine Learning. Yeah, so this is the agenda today. So we're getting started with the assignments and becoming familiar with vocabulary and key concepts. And at the end, you can ask questions about the lecture or the course. So it's going to be two mandatory assignments. The one is about end-to-end machine learning project that we will start on tomorrow. So it's going to be a Kaggle challenge based on chapter 2. And you will learn about the main steps you will go through as a data scientist in a machine learning project. So in assignment 2, you will work on your very own machine learning project. So you will use your experience from assignment 1 and select the data set from a list I will publish later in this course, and also working on model deployment. So here I will recommend you to make something you can be proud of. So I hope most of you have gone through this module 0 now, getting started. Yeah. And I've installed all the environments you need. So today we are going through some vocabulary and key concepts. So machine learning versus deep learning, machine learning engineering, limits of machine learning, different types of machine learning, and ingredients of machine learning, a bit of history at the end. So what is machine learning and deep learning? So machine learning is the study of computer algorithms that learn by experience without being explicitly programmed. So many of you will get your first hands-on experience with machine learning today in this notebook that you will work on yourself after this presentation. Kjetil, could you mute yourself, please? Thank you. So in traditional machine learning, the data and the results is executed on the computer to create the program, as I mentioned last time. However, the data you pass into the computer requires feature engineering in real-world problems. So you need to use domain knowledge to construct transformation of the original features. And it's often critical to the performance of machine learning algorithms. So coming up with features is difficult, time-consuming, and requires expert knowledge. So we will look into it later in this presentation or lecture. So here is a couple of features that could be used, like origin, size, weight, function, and so on. And as I mentioned last time, you can see that Alaskan Malamutes and Siberian Husky have different tails and so on. That is easy to see in pictures, but not that easy to put in here or you see that it is described here. So you can put it in as a discrete value. So however, in deep learning, you can just give in the picture and the labels and create these rules. So here's another example of a project I worked on. So pulmonary nodule classification in lung cancer. So it's about lung cancers that accounted for nearly 20% of all cancer deaths in Norway in 2017. So diagnosing and following up these patients requires identification of malignant tumors that appears as lung nodules, as you can see here. So it's difficult to distinguish between benign and malignant pulmonary nodules, since the difference can be subtle. However, it's an important information source for diagnosing and evaluation of progression and treatment response. So in traditional machine learning, you have to come up with these features yourself, such as calculating the size, shape of the knot, and so on. This requires some work from an expert before we can send it into a model. So in deep learning, we can only pass the raw image to the model and get the prediction based on the features that the model has learned by looking at different images with true labels. So you can have several images with long nodules in different regions, and it will generalize if you have a large amount of data to that. So just a notification there, deep learning can also be used for tabular data. However, it requires feature engineering here as well. So yeah. So deep learning requires a lot of computational power to run on. So a GPU is a specialized processor with dedicated memory that conventionally perform floating point operations required for rendering graphics. So GPUs are specifically designed for performing more complex mathematical and geometrical calculations like light, shadow, pixels on the screen. So training of deep learning models consists of matrix calculations, the speed of which can be greatly enhanced if the computations are carried out in parallel. So GPUs are optimized for training artificial intelligence and deep learning models, as they can process multiple computations simultaneously. So if you're interested in this and you will continue on your master's, then it is a course in this where you can learn more about it. So it's a hyperledger with deep learning. So deep learning developments in recent years have generated an enormous amount of hype and unrealistic expectations. The media and technology experts focus on the most striking consumer-focused application of the technology, like autonomous vehicles, chatbots, and so on. So deep learning is only useful in certain limited situations, and traditional machine learning algorithms are more broadly applicable in industry. So in practice, a lot of software engineering is needed to develop and implement machine learning systems. And in the final module of this course, Machine Learning in Practice, we will take steps towards an understanding of this. And hopefully we will have some guest lectures as well. So limits of machine learning. Machine learning is bounded by the quality and quantity of training data. So things that can go wrong, we will look at in a couple of seconds. So data scientists spend significant part of their time on cleaning and organizing their data. So here's an example with label noise. So if you want to classify grizzly bear and black bear, it should have been black bear here, sorry. And you get this final picture in, then there will be a noise when you train the model. So I will update this slice after this lecture. So examples of bad data, things that can go wrong. So poor quality data, noise and outliers, as we saw in the previous slide, insufficient amount of training data. So it takes a lot of data for most machine learning algorithms to work properly. So even for simple tasks. So, and data acquisition is very time consuming. So it's not always possible to get more data. And irrelevant features. So a model can only learn to operate on the pattern seen in the input data used to train it. So if you have only garbage in, it will be garbage out. And the last one is non-representative training data. So assumes so machine learning models assumes that future data is similar as training data. So now we are going through like machine learning versus deep learning and machine learning, a bit of machine learning engineering and limits of machine learning. So there are 3 different types of machine learning. Supervised learning, so algorithm learns from training data where the label is included, and the goal is to make predictions on future data based on these examples. So it's divided into classification and regression problems, where regression looks at continuous values, while classification looks at discrete values, where you use discrete values. So it has been a great success in recent years, and it's behind essentially all economic value in AI. So here is examples with regression where you want to predict the temperature, while in classification, you want to predict, you set a threshold where you want to say if it's hot or cold, so discrete value and continuous value. And then you have unsupervised learning. So algorithms learn patterns and relationships from unlabeled data, like clustering, dimensionality reductions. So here you have an example of clustering. So you try to cluster into 3 different clusters. And the final one is reinforcement learning. An agent tries to maximize a reward by taking actions in an environment. Based on the effect of the actions, the agent learns what is wise to do, like you have seen in Dota 2 that I showed earlier in one of the deep learning examples. So you'll also hear an example with an agent module does some actions in the environment and gets rewarded or punished based on the action in the environment. So in this course, we will look at supervised learning, since it's only a 5-credit subject. So supervised learning is about function approximation, as I mentioned last time. So X could be an image. The Y could be what's in the image or is what's in the image. And the F is the function, the model. So we select the model ourselves, and the theta is the parameters. What the parameters should be is determined by learning. So here's some ingredients of supervised learning. So data, labels, training data, train model, performance measure, and propose. So data could be feature vectors, images, audio. Labels could be like a scheme element, cat, dog, horse, cancer or non-cancer, and so on. And training data is just data and label, which is the input to the machine learning model during training. So a train model is a function where you pass in an instant and get a predicted label or value, so a hypothesis. So performance measures is for how does the model perform on the target task. So there we will look at loss, performance metrics, which is used as a feedback signal. The purpose of the train model, you need to also look into that, which kind of business impact it could have. So yeah, machine learning is nothing new, as I also mentioned in the previous lecture. It has been around for decades. So here is like from 1700, and it has been going on until now. So now you will work on a first example of machine learning and get some hands-on experience by using these Jupyter Notebooks. So why do we want to use Jupyter Notebooks? Some of you would probably think about that. So Jupyter Notebook makes it easy to explore and plot the data. Rather than writing and rewriting entire program, you can write lines of code and run them on one at a time. So notebooks have rapidly grown in popularity among data scientists to become the standard to quickly prototyping and exploratory analysis. So this is a blog post from 2018 written by people at Netflix. So Netflix uses a variety of tools to do data analysis. So one of the big ways the data scientists and engineers at Netflix interact with their data is through Jupyter Notebooks. So I think we can take a quick coffee break now, and then you can start on the first example of machine learning. And it's also videos from previous year that you can use. However, it is in Norwegian, but all the text is in the notebook. So yeah, I think I will stop the recording now. So